When working with large sets of data, it's often helpful to organize the data in a table called a frequency distribution. Frequency distributions organize the data into classes, making the data more manageable and revealing the nature of the distribution of the data. So let's look at an example. Here we have the scores of 50 students who took an 80-point statistics exam, and we want to organize this data into a frequency distribution. Well, usually we use 5 to 20 classes. So we have to decide as the researcher how many classes we want to use for our data. And say for the purposes of this example, we decide to use 7 classes. Okay, so what are these classes going to be? They're defined by a lower class limit and an upper class limit and their class width. So we've got to come up with a decision on those. In order to compute the class width, there's a little calculation we can do where we take the range of the data and divide that by the number of classes. Well, recall the range is just the maximum value minus the minimum value. Okay, so let's look at our data and see if we can find the maximum value. See, 20, 50, 30, 75, that's the largest so far, 77. Is anything larger than 77? There's a 72, so 77. So here's our maximum value. Now a minimum value, 23, 12. Let's see, anything else in the teens? No. So this 12 is our minimum value. It may be sometimes, if you have a lot of data, you may have to actually put it in order, in ascending order, but usually you can scan through there and find your maximum and your minimum. So our maximum value is 77, our minimum value is 12, and we divide that by our 7, which was the number of classes. So 77 minus 12, that's 65 divided by 7, and that comes out to be 9.3. Alright, this is telling us that we need a class width of 9.3. Well, we don't want to work with decimals here. We can't just include a portion of one of these scores, so what we need to do is round that. And we wouldn't round down because we need at least 9.3 if we're going to have 7 classes. So we're going to round that up to 10. So our class width now is going to be 10. Okay, that helps, but now we still don't know what that first class is. We need a lower class limit and an upper class limit. Well, lower class limit has to go at least as low as 12 in order to get that lowest value. And a lot of times you may decide, well, I'd like to work with nice rounder numbers than that, so it's perfectly fine for us to say, well, let me just start at 10 because I know that'll include my 12 and move on from there. So let's say that our first class will have a lower class limit of 10. Well, then what's the upper class limit for the first class? Well, we said it's going to have a width of 10. And what that means is, with our whole number data here, it means we'll have 10 possible scores in that first class. So a score of 10, or 11, or 12, 13, 14, 15, 16, 17, 18, 19 would be the 10th possible score in that class. So our upper class limit would be 19. Okay, so now that we know that, we can set up our whole table and organize into a frequency distribution. So let's do that. So our table will have our classes, and each class will have a lower class limit and an upper class limit. So we said our first class would be the class from 10 to 19. Okay, what would be the next class? Well, after 19, the next score in the beginning of the second class would be 20. And again, we want 10 values in here. The width is 10. So it would go to 29. And we can see the pattern falling out here. 10, 20, 30 to 39, 40 to 49, 50 to 59, 60 to 69, and up a little bit, 70 to 79. And since our maximum value is 77, now we can sort all our data into these classes. Okay, another term that we use when we're working with frequency distributions is the class boundaries. Okay, so let's find out what they are for each of our classes. The class boundaries they're used to separate the classes also, but they don't have any gaps. So sometimes it's easiest to start with the boundary between the first class and the second class. So it's the value that falls between the number that falls between the lower class limit of the first class, the upper class limit of the first class and the lower class limit of the second class. So we just basically take an average of those and find that that number would be 19.5. That's the number between 19 and 20. And so in the class boundaries, the lower class limit here is the same as the upper class limit here. This is the number that's the cutoff between those two. Now see, our data doesn't have decimal places. It doesn't go to one decimal place. So it's really clear where the number 19 would fall and where the number 20 would fall because we don't have data to one decimal place. So this illustrates our boundaries. And again, we've got that class width of 10, so we could just go down the column adding 10. Adding 10, adding 10, all the way down. And 59.5 to 69.5, and our last 69.5 to 79.5. Now I didn't do that first lower class limit because it was easier to start here and then figure out what it should be. So now I can just subtract 10 and see this should be 9.5. Okay, so now we have our class boundaries. Okay, another term that we'll use and is important in working with frequency distributions is the class midpoint. And that's exactly what it is, the middle point in the class. You actually take the average, and so let's see what that would be, of our classes. The lower class limit of 10 plus the upper class limit of 19 divided by 2, and we see that the class midpoint for the first class is 14.5. So from there we can actually compute, again, using our class width because it has to continue. So we could take the average of 20 plus 29 divided by 2, that average for the second class, or just add 10 to get 24.5, 34.5, 44.5, 54.5, 64.5, and 74.5. Okay, so we've determined what the classes are, the lower class limit and upper class limit, what we mean by class boundaries, and then what we mean by class midpoints. Alright, now to get our data in the table, we want to find the frequencies, we'll label that with an F, for each class. So we'll go back to our data, and now we're going to look for how many values fall in the first class, 10 to 19. So here's one, and as we go I'll just cross them out so I'll know I got it. 1, Here's 15, that would be in that category. 2, and I don't believe there were any others. Okay, so we have 2 in our first class. The next class is 20 to 29. So here 23, anything beginning with a 20. 26, 21, so that's 3 now. 27, that's 4, and that's all the 20s. So we have 4 in the second class of 20 to 29. Third class is 30 to 39. So we have 1, 2, 3, 4, 5, 6, 7, and I believe that's it, 7 in the 30 to 39 class. All right, 40 to 49. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 in the 40 to 49 class. Okay, 50 to 59. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 in the 50 to 59 class. 60 to 69. 1, 2, 3, 4, 5, 6, 7, 8. 8 in the 60 to 69 class. And finally in the 70 to 79 class, 1, they should just be the ones that are left, right? 2, 3, I believe that's it, 3. Alright, so we'd want to check to be sure. We said that our sample size was 50. We have 50 student scores here, so this should add up to 50. What's that? 6 and 7 is 13, and 6 is 19, 27, 30? 3, 4, 5. Yes. So we've accounted for all the scores, and we now have our data in a frequency distribution. Finally, we can look at our frequency distribution and get some idea about the shape of the data, the shape of the distribution. Looking at our frequency column, we notice that the frequencies start in the first class low and gradually get larger to a peak and then drop off. Now, that's what we see with a normal distribution. So it's not perfectly normal. We see that peak doesn't happen till down here into the fifth class, but it's definitely got that feeling of starting low, rising to a peak, and then dropping back down. So we might look at this and say that this distribution looks to be approximately normal. Now we might determine that a distribution, and this is the distribution we're really interested in, this normal distribution. So we might be looking to see, is it approximately normal or is it not? So it wouldn't be at all, we wouldn't say that at all if we saw like a peak early or maybe 2 peaks with a drop between them. So we want to look at that frequency column and see what you think. Does it tend to rise to a peak and then drop down a little bit? Then we can say it's approximately normal. Otherwise, we would say that it wasn't.